So the question today is, how can you compare strings in Java? When writing new code or maintaining legacy applications, you may see some code that uses different ways to compare Java strings when checking for equivalency. You'll sometimes see the double equals operator used. You may also see the not equals operator used, which is the same type of comparison, but checking to see if strings are not equal. Other times you'll see the dot equals method from the string class used to do the comparison. So the question is, which technique should you use? Is one better than the other? And most importantly of all, why do you sometimes get different results than you expect using the double equals operator? Let's explore the solution by looking under the hood to see what Java is really doing. First, let's declare a variable called var01 of type string. Then we'll initialize it using the new operator and set it equal to a string object, which is set to hello world. After doing this, var01 references some location in memory where the string hello world is stored. Next, we'll declare another variable, var02, and initialize it with the new operator, and also set it equal to the string hello world. So now var02 also references a location in memory where the string hello world is stored. In our code example, we use the double equals operator to check to see if var01 and var02 are equal. If they're equal, our expression will return true, otherwise it will return false. The result is false, meaning the two values are not equal. In the coding section, we'll run this code so you can see for yourself, but for now, just trust me. So why are the variables not equal, at least according to the double equals operator? The double equals operator tests to see if the references are the same. In other words, do the variables refer to the same object? Think of it as a location in memory, although it's not quite that simple since the Java virtual machine manages the runtime environment. Because we used the new operator to construct the objects, they ended up being created on the heap and are in different memory locations. In our next example, let's declare a variable, var03, and initialize it with the new operator once again, setting it equal to a Java string containing the message hello world. Next, we'll declare a variable, var04 of type string. However, this time we'll set it equal to var03. As you can see in our diagram, the green var04 reference now points to the same location where the hello world message is stored and that var03 references. Now let's run the same code again that we did on our last slide. We'll check to see if var03 and var04 are equal using the double equals operator. If they're equal, our expression will return true, otherwise it will return false. This time our expression will return true. Again, trust me on this, we'll see some real code running in just a moment. Since the two variables var03 and var04 reference the same location, the double equals operator will return true. Next, let's declare a variable var05 and initialize it with the string hello world once again. Notice this time we don't use the new operator. However, just like in our first two examples, the variable, in this case var05, references a string containing the text hello world. Now we'll also declare a new variable var06 and initialize it with the string hello world, also without making use of the new operator. In our code example, let's compare the variables var05 to var06 with the double equals operator. In this case, we get back a value of true. What this is saying is that var05 and var06 reference the same string. Now let's try the dot equals method of the string class and compare the contents of var05 to the string var06. Once again, we see that the answer is true. So for var05 and var06, they're equal using either the double equals operator or the equals method. On the last slide, we saw that var05 and var06, when created without the new operator, are equal using either the double equals operator or the dot equals method. Why is that? First, a little review on Java strings. Java strings are immutable, meaning you cannot change individual characters of the string. So just as the number 99 is always 99, the string hello world cannot change. However, you can change the contents of the variable, for example var05, and make it refer to a different string. Because strings don't change, they can be shared. Strings are placed in a pool where they can be shared. This process is called interning. The designers of the Java language decided that this would be a means of creating a more efficient language. So here, var05 and var06 refer to the same string literal from a common pool. var01 and var02 represent two distinct objects. Memory from these strings is allocated on the heap, and therefore they're in different locations in memory. So with all of this as background, what's the right answer? Should we use double equals or the equals method? In almost every case, you'll want to compare the contents of two strings, not their locations, so the equals method should almost always be used. Using double equals may result in intermittent bugs that seem to work some of the time and fail other times. These are among the most difficult bugs to track down, so you want to do yourself a favor and use the dot equals method. There can be a slight performance increase using the double equals method, but it's far better to have correct working code than fast, buggy code. Alright, let's switch gears and take a look at some actual code. We'll be using the IntelliJ IDEA IDE in Windows 10. I've already got the project set up along with the package structure, so we'll go ahead and create a Java class. We'll call it compareStrings01. We'll use the IntelliJ shortcut PSVM to create our main method. Next, we'll create two variables, var01 and var02, and initialize them to a new string, both with the value of hello world. Now let's add some conditional checks using the if statement. First, we'll check to see if var01 is equal to var02 using the double equals operator. If they're equal, we'll print out the message equal compare is true. Otherwise, we'll print out the message equal compare is false. Now let's run the code. When we do, we see that we get the result of false. This confirms what we saw earlier on our slides. Now let's change the double equals operator to the dot equals method to compare our two variables. And we'll change our messages accordingly. Now let's run that code. And when we do, we see that the dot equals method returns true, meaning the contents of the variables or the message hello world is the same. Now let's change the variables var01 and var02 so they're initialized with the string hello world without use of the new operator. We'll leave the dot equals comparison, and we'll copy that code down below and change the dot equals method to the comparison operator using the double equals operator. And we'll change our output message to reflect this change. Now let's run that code. We'll see that both dot equals and double equals gives us a true result. Now let's talk about comparing strings in Java and how it can impact the security of our code and our application. To start with, is there any concern around using the double equals operator or the dot equals method in our code from a security point of view? The answer is most definitely. Findings of this type are usually considered to be low risk or informational by most static analysis tools and ignored by many developers. However, as we've seen in the comparisons above, performing a comparison using the wrong operator can produce inconsistent or wrong results, which can introduce business logic flaws into the application as well as security vulnerabilities. Taking an unintended path in the code can impact the security of the application. For example, improper authentication logic may be executed, or an incorrect role or privileges may be assigned to a user, giving them elevated access or access they're not entitled to. Other issues may arise that allow an attacker to bypass checks that give them the leverage they would need to compromise the system. There are several CWEs that exist for this and for related problems. Here's a partial list. CWE 957, use of the wrong operator in string comparison. CWE 480, use of incorrect operator. And CWE 595, comparison of object references instead of object contents. Thanks for watching. We hope you enjoyed this video and learned something. Right now, while it's fresh in your mind, please go to www.beginsecuretraining.com to get our free ebook on how you can write more secure code in Java. When writing code, remember to always begin secure.